All right, in our last video, we introduced this notion of what a limit is, and I'd mentioned that I wanted to take a look at what happens if we're given a function in the context of a table of values. So let's take a look at a particular example here. So I'm just going to enter a rational function into my calculator because it'll be handy for generating values. So we'll have x squared minus 1 up top. Down below, we'll have x squared plus 4x minus 5. So, all right, so double checking and making sure I did not mess anything up. Yep, that is what I was wanting to see. My apologies for the awkward screen wrap on the TI-83. An 84 model, I think, would just kind of scroll, off to the side. But anyway, you may notice this is sort of like that quadratic example with the hole at the origin that I used in the last video, because if you tried to look at what was happening right at x equals 1, if you plug x equals 1 in here, you get 1 squared plus 4 minus 5. That's 0 in a denominator. That's bad. So we can't plug 1 into this thing. You may also notice that we get a 1 minus 1 equals 0 up top in the rational function. And like we've said before, that kind of indicates that there's something we might be able to do to clean this up. We'll talk about that next week. For now, let's just try to investigate what's happening as we let this function get close to 1. Now, I could draw a graph and then we trace along like we did with the bug, but like I said, I wanted to investigate this with some values. So again, just double checking. In my table set, I want to make sure it's set up so that I can ask, so that it asks me for independent variables. So I'll go in here, and now let's pick some numbers that kind of close in on 1 from one side or the other. So this isn't terribly close, but we can start with 2, and we get 0.42857. Okay. Now again, that's still not terribly close to 1 in the grand scheme of things, so let's close in a bit more. 1.5. All right, well, we came down a bit, so we're at 0.38462. Let's try getting even closer. 1.1. Now we're at 0.34426. And if you wanted to get more precise, you can move the cursor over that guy so you can see you got more decimal places. Now let's keep sneaking in ever closer. 1.01 gives us 0.33444. You may be able to see where this is going at this point. I'll add in another 0. 0.33344. One more time. And you can see it looks like we're closing in as like the further down we go, the more we're just creating digits that are 3. So it looks like 0.333, a whole bunch of 3s. Hopefully that triggers something in your memory banks that we're dealing with. It looks like it's getting close to 1/3. I nearly said 1/2. Oops. Well, let's see what happens from the other side. What if we're dealing with values smaller than 1? Does that change anything? So let's try 0. We have 0.2. You could have plugged that one in directly easily enough. But 0.5. Now this time we don't want to do 0.1 because that's actually getting farther from 1. So let's do 0.9 instead. And you can kind of see what's going on here. 0.99. Oh, look. 0.999. Yeah, it looks like pretty much the exact same thing. What you want to bet we're going to have that exact same thing, but with a 2 at the end instead. 999. Shock and dismay. All right, so it looks like the same thing is happening. We're getting closer and closer to that same number of 1/3, whether we approach from one side or another. So our numerical data are kind of suggesting to us that the limiting value of this function as we get close to 1 would be 1/3, even though we can't plug x equals 1 into this function directly. So let's take a look at one more example. So, whoops, I don't want to look at a graph. Shoot. All right, so let's come back in here and clear this out. This one is a bit trickier to filter into the system. So let's see, I've got square root of x plus 4 minus 2. So I've got that entire thing is going to be living over top of just the variable x. And we're wanting to see what happens as we let x get close to 0 in this instance. So again, you can check if you plug x equals 0 in here, you'd get the square root of 4, that's 2. 2 minus 2 is 0 up top, 0 down below. So yeah, that same issue where we can't actually just plug in the number and see what's happening. All right, so now I gotta, so you'll notice right here, I forgot to clear these numbers out. So if you try to plug in x equals 0, it gives you a big fat error message. So, all right, let's try closing in on 0 from one side, than the other. Let's see, so 1, hopefully you get the idea here. I'll start from 1, 0.5, 0.1, 0.01, 0.001. And you'll notice it looks now, again, you can kind of suss out the pattern. Shucks howdy. Note, the calculator will bump into scientific notation here. 1 times 10 to the negative 4th. That's fine. And again, it's not exactly 0.25. It's actually, just as accurate as the little table will display. That's what we're looking at. It rounds it to 0.25000. It just doesn't show all of those, extra, decimal places. So from the one side, looks like we're getting close to 0.25 or 1/4, right? So trying from the other side of 0, if I were really smooth about it, I could just sneak negatives into these things. But I'm just going to do it this way. I'll just type in minuses. So we started at 0.26, 795, creeping on down the line. You'll notice, it looks like the same sort of thing is happening, right? So we're just on the opposite side of our number in question. So negative 0.0001. So then it gives me negative 1e to the negative 4. And again, not exactly 0.25, just close enough that to the display that's showing up in here, it can't tell the difference. So from either side, once again, it looks like we're getting close to 1/4, and so looks like a reasonably safe bet to call that our limiting value as we let this function close in on 0. All right, so you've noticed so far it might have felt maybe a little pedantic. Why is he checking from values on both sides of the target point? Why did we need to go through this process of changing all of these positive numbers to negative numbers just to confirm what's happening on the other side? That's a pretty excellent question, and it's actually the subject matter of the next video I wanted to put up on this, so keep on watching.